Welcome. In this episode, we have a PC build with an AMD 7800X 3D and RTX 4090 Founders Edition water-cooled in the O11 Dynamic Evo. We will build a custom loop using components from Watercool, Optimus, EKWB, and use Heatkiller black soft tubing. We will fill the custom loop and perform testing to obtain thermal, power, and performance results. This is the Vector Network, and let's begin. The build begins with the AMD Ryzen 7 7800X 3D. This AM5 CPU uses an LGA socket where the pins are on the motherboard, whereas AM4 had them on the back side of the CPU. In addition, this model and AM5 CPUs have an integrated heat spreader, IHS, with open cutouts for capacitors. The ASUS ROG Strix X670E-E motherboard has the required power delivery, PCIe slots, and connectivity, and uses a monochromatic colorway with a black PCB and dark metallic heat sinks. Let's go ahead and drop the CPU into the socket. The Optimus Foundation AMD CPU block is compatible with the AM5 platform and its LGA socket. This Optimus block is assembled with metal screws into metal threads. This CPU block uses cast acrylic and its proprietary nickel plating process designed for the cold plate's fins and micron channels. The Optimus cold plate is machined to less than 1 micro-inch in flatness, which requires proprietary diamond tooling that results in a mirror finish. Let's add a couple of plugs to the block while it waits to be installed. Let's continue by removing the stock CPU cooler brackets on the motherboard. And then screwing in the 4 Optimus mounting standoffs. Let's grab the Noctua NA STP G1 thermal paste guard for AM5 CPUs. For thermal paste, let's use the Noctua NT H2. The CPU block is next, and peeling off the plastic film reveals the mirror finish, and then we can drop the block right on top and secure it with the 4 thumb screws. Besides using a screwdriver to remove the stock brackets, the installation of the Optimus CPU block is done completely by hand. This build will use fittings from Optimus, EKWB, and Koolance. Let's add 2 sets of EKWB torque extenders and 90-degree angled adapters along with Koolance QT3 male fittings. Let's drop in a kit of 64GB G.Skill Trident Z5 Neo 6000 megatransfers memory. Installation of the NVMe storage requires first removal of the heat sinks. The NVMe slot at the bottom left will not be used as it shares PCIe lanes with the primary 16-lane slot. We will add 2 NVMe drives for additional storage and another Samsung 980 Pro NVMe as the primary boot drive. We can then peel the film off the thermal pads and put the heat sinks back on. We will be using the Lian O11 Dynamic Evo in black. For an inverted PC build in the white Evo, please click on the link in the top right hand corner. For cooling, we will be using 2 Watercool Heatkiller 360L radiators that are 48mm in height and each using a different set of 3 fans. For the first radiator, we're using 3 Phanteks T30s. These fans are 5mm longer than standard size, so let's use 35mm radiator screws. This radiator will be positioned upright on the side. Once secured to the removable side bracket, we can slide it in and then lock it into place. For the runs, we'll use Watercool HeatKiller EPDM 16x10 black soft tubing. What I noticed is that the Optimus Flex compression fittings are a dead-on fit for the Koolance QD3 fittings in the same 16x10 size. Once clicked into place, the quick disconnect fitting can be rotated to hide the lettering. Now it's time to assemble the reservoir. We're using the Watercool HeatKiller 200 multi-port tube reservoir unit in black with a single silver anodized strut. This is a multi-port model and the largest size at 200mm. Rather than the different grades of acrylic, this tube is made of glass. We will be using a Watercool Edition WCP D5 PWM pump. The pump is fed directly from the reservoir without any additional parts. The water-cooled decoupling unit used in connection with the reservoir mount is intended to reduce vibration from the D5 pump. Next to install is the removable bottom case bracket. We'll use an EKWB torque 90-degree adapter with an Optimus Flex compression 16x10 fitting. Then another 90-degree adapter and male quick disconnect fitting and an EKWB drain port. Then we can drop the reservoir into the case. We are using the RTX 4090 Founders Edition housed in the Watercool HeatKiller V Pro water block. The unbox, install, and thermal episode of this HeatKiller GPU block resulted in the cold plate that was clearly tinted red. For an initial effort, Mayhems Blitz Phase 2 cleaner was used. Afterwards, more cleaning was still required. So let's go ahead and open up the GPU block by first removing the I/O bracket. Then we can slide off the black anodized aluminum housing, followed by removing 20 torque head screws, removing the top, grabbing the jet plate, using Q-tips and a toothbrush to adequately clean the fins, cold plate, and flow paths. Then we can reassemble the block by dropping in the small O-rings and jet plate, followed by the large rubber O-ring. The top goes right back on along with the previous 20 torque head screws. Followed by the black anodized aluminum housing and the I/O bracket. We will use the Lian vertical GPU mount for the O11 Dynamic Evo. Let's add 2 sets of 90-degree adapters and flex compression 16x10 fittings and a Koolance sensor. Let's slide the PCIe 4.0 riser cable into the motherboard and then secure the mount into the case. Let's continue by connecting the GPU block to the loop. We are using 3 male quick disconnect fittings, 2 on the CPU block, 1 on the reservoir, and 2 female disconnect fittings on the GPU block, so either block can be independently disconnected and serviced without the need to drain the loop. The power supply is the Be Quiet Dark Power 13 850 watt unit that drops into place and then secured to the case. The second Watercool HeatKiller 360L radiator will be using 3 Noctua A12-25 fans at a standard 25mm thickness. Once installed, we can secure the top case bracket to the radiator and install 2 torque extenders, a 90-degree adapter, and 2 flex compression fittings. Once installed, we can then slide it into place into the case. The last 2 runs of EPDM Heatkiller 16x10 tubing remain. The Aquacomputer Quadro will be used to control the custom loop. Let's plug in the Phanteks T30s and Noctua fans and the D5 pump, followed by the ambient temp sensor, the coolant sensor, and the USB cable for the motherboard, then the Molex connection for power. We are using a coolant with low conductivity, the Aquacomputer Double Protect Ultra in clear. Click on the link in the top right hand corner for the RTX 4090 Founders Edition full teardown and thermals video. Stay tuned as the testing is coming up right now. Although shown open on screen, to obtain the results, 3D Mark Speedway stress test was run with the Lian Evo case completely enclosed with the optional mesh front and ambient room temperature at 21 degrees Celsius. For testing, the Phanteks and Noctua fans were set to 60% speed and the D5 pump was set to 40% speed. For 100% power limit stock thermals, the GPU core temperature rose 26 degrees Celsius from an idle 26 to 52 degrees Celsius under load. GPU memory temperature rose 28 degrees Celsius from an idle 30 to 58 degrees Celsius under load. Lowering the power limit to 70%, the GPU core and memory temperatures were 7 and 4 degrees Celsius lower, respectively, compared to 100% power limit. Undervolting the card to 0.95 millivolts and adding 200 MHz to the core to arrive at a targeted 2,735 MHz core clock. The GPU core and memory temperatures were 3 and 0 degrees Celsius lower, respectively, as compared to 100% power limit. Overclocking by increasing the power limit to 130%, adding 200 MHz to the core and 800 MHz to the memory clock. The GPU core and memory temperatures were 3 and 4 degrees Celsius higher, respectively, as compared to 100% power limit. Although Speedway is a GPU benchmark, the CPU temperature rose up to 8 degrees Celsius to 46 degrees Celsius under load across the different settings. The Noctua and Phanteks fans averaged approximately 1400 and 1200 RPM respectively. The D5 pump averaged just under 1450 RPM. At this combined RPM level, the approximate and average noise was recorded to be between 35 and 40 decibels. The 100% power limit is at 450 watts. Undervolting the card reduces the wattage from approximately 420 at 93% to 345 at 77%. A 75 watt or 18% reduction. Frames per second was recorded during 3D Mark Speedway stress test. As stock, the FPS was 99, and at 80% power limit, the FPS was at 95, a 4 FPS or 4% reduction. Like the video by clicking the like button. If this is your first time here, go ahead and subscribe to the channel. This is the Vector Network. Please click on the bell for a notification when the next episode airs. Click on the links here for more videos like this, including video card and water cooling component teardowns, unboxings, and thermal testing for water-cooled PC builds. Thank you, and I'll see you at the next episode.